In this video, we're looking at question 3 in the problem set DLI Physics Derivatives in Mechanics. We're told Oompa Loompas are pulling a 2 kilogram crate of golden eggs along a rough but level surface, so the mass is 2 kilograms. And it's determined the position of the block as a function of time is given by this expression here. We're asked A, find the speed of the block at t equals 2 seconds. So the first thing we note is that the speed is the time derivative of position, and then we use our polynomial rule, which is to multiply by the exponent and lower that exponent by 1. So applying that polynomial rule for derivatives, we see that v of t is 3 times 0.3, that's 0.9, times t, and we lower the power by 1 from 3 to 2, minus 0.1, to be consistent here, 0.9 t squared minus 0.1, and we need to lower the power by, we need to bring the power down and lower the power by 1. So here we have 0.2 t, bring the power down by 1, t to the 1, plus, here we have 0.2 t to the 1, so we're bringing down a 1, lowering the power to 0, which makes this term a constant, so this is plus 0.2. So there's our expression for velocity as a function of time. That shows us how this crate is moving as a function of time in terms of what is its velocity at each time t. To find the velocity of the block at t equals 2 seconds, we just plug in t equals 2 into each term that has a 2 here. So this would be v of 2 equals 0.9 times 2 squared plus, minus, that is, 0.2 times 2 plus 0.2. So I have 0.9 times 4 is 3.6 minus 0.2 times 2 is 0.4, 3.6 minus 0.4 is 3.2 plus 0.2 is 3.4 meters per second. Moving on, we're asked to find an expression for acceleration as a function of time. To do that, we note that acceleration is the rate of change of velocity, so it's just the time derivative with respect to time of this expression here. So a is a function of time, a of t is the derivative of this expression. We bring down the exponent and lower the exponent by 1, 1.8 t to the 1 minus 0.2. We brought down the exponent here and lowered it by 1. T to the 0 gives us a constant, and the derivative of any constant is 0. So there's an expression for acceleration as a function of time. Find an expression for force as a function of time. Here, all we have to do is note that force is the acceleration divided by the mass. Mass is not a function of time in this question, at least. So this is 1.8. The mass, remember, is the mass is 2.0 kilograms. So we have, dividing everything by 2, 0.9 t minus 0.2. 0.2 divided by 2, 0.1. And the units of that will be newtons. Find the kinetic energy of the block. Ke equals 1/2 mv squared. Initial kinetic energy. So we want this at t equals 0. All we have to do is take our expression for velocity, which is right here, and plug in t equals 0 to find the initial value. So this term disappears at t equals 0. It's equal to 0. Second term equal to 0. We have only the constant term. So velocity at t equals 0 is 0.2. So we're going to have kinetic energy initial is equal to 1/2 the mass, which is 2. Perhaps someone chose 2 to cancel that 1/2 to make this number simple to calculate. And velocity we see is 0.2 at t equals 2. So we have 0.2 squared. 1/2 times 2 is 1. 0.2 squared is 0.04. And this is an energy, so our units are joules. Find the change in the kinetic energy of the block from t equals 0 to t equals 2. Well, we know the initial kinetic energy. Now we just need to know what is the velocity at t equals 2. V of t, remember, is given by this expression here in part A, 0.9 t squared minus, let's zoom out a little bit, 0.9 t squared minus 0.2 t plus 0.2. So the v at 2 will be 0.9 times 2 squared minus 0.2 times 2 plus 0.2. Kinetic velocity at that time then is going to equal 0.9 times 4 is 3.6. If we already found this number. Speed of the block at t equals 2 seconds, 3.4 meters per second. So finding the kinetic energy at that time, Ke at t equals 2, is equal to 1/2 m v squared. We know 1/2 m is 1/2 of 2, which is 1, and v squared 3.4 squared, which is 11.56 joules. So taking the change in kinetic energy, we have 11.56 minus 0.04. So that means the change in kinetic energy is 11.52 joules.